Okay, so in last video we discussed about water potential. Basically, we are discussing water transport. We are done with the water potential, but let me give an overview so that you understand other topic nicely. Water potential was simply if this is the container, this have water molecules. So you'll see that here these are moving. So that motion energy or kinetic energy is simply energy which point motion. So kinetic energy which help in movement, motion, and it's all in what? In H2O, because these are H2O molecules. So this means this is a potential where kinetic energy is added. So it's like water potential simply means where kinetic energy help in movement. So that's called as water potential. Here it was denoted with the psi and solute, which was not directly but inversely proportional to water potential. So it was denoted by this psi. Here psi is like psi is written like this but denoted by this one. Here we are writing about water potential, so it will be psi w. W represent it's a water potential because psi is symbol of all the transport like osmotic pressure, solid potential and all. So this is a basic concept about this one, water potential, but today's topic is solid potential. So let's see what does that mean. So let's see. First thing you'll see, if this the container I'm taking two container. One here, these are the container. Here water is present, and what we are going to do, we are going to add solute concentration. So this is solute. Okay, so here you'll see the solute is going to be reduced here. Wait, this is solute which is added in orange color. You'll see that solute, when solute is added, so this is a membrane, right? And here if we add solute, so this means what's going to be happen, here is a membrane and solute is added near that. So solute membrane, solute which is present near the membrane, so water will like not able to move as fast and as concentration which was going before. So water concentration become less in movement just because membrane is there, and we add a thinner like salt or sugar as a solute, so we'll see something like a movement and they're not able to move. So this means if I just write a definition simple, it would be solute which reduce kinetic energy of water molecule. This is about solute. So solute which is always negative because solute always had, why solute is always negative, because it always help to reduce kinetic energy, and the one who oppose negative and opposite force, that's called as negative. So I'm sure it's clear to you. That's denoted by this is psi, and we write S. S represent this is a solute, and this is directly proportional to 1, not directly but inversely to water potential, or I can also write like this. So I'm sure it's clear to you. So yes, this is a basic concept. I hope it would be clear to you. Then comes our another topic which is present in a book, which sometimes is quite confusing as well. That's osmotic pressure. So osmotic pressure is what? It's a if I just write a definition first, it would be when pressure which is needed to stop osmosis to balance solute concentration is called as this one. So I'm sure it would not be clear to you as I've just written definition. So let's start explaining with these are the container. Here you see the flow So what you'll see here, pure water, which is pure water is here, and here you will see that something else like solute is high. Solute can be sugar or can be salt. So you'll see that here solute and they have a transport. So we know osmosis is simply a movement of water from higher concentration to lower concentration. So here we see that water is low and here solute is high. Like water is more here, solute is more here, so it will move from higher to lower. So water move from higher to lower concentration, so here it's higher, so it will move to lower. When it comes here, so these both are not equal, right? So we need to apply force, not force, but we need to make sure that there will be one condition like equilibrium, where you'll see that they both become equal. When they both become equal, that is called as osmotic pressure. This means they both have balance both. Like here you will see solute amount as same as here water and solute becomes. So I'm sure it's clear to you. So it's a simple osmotic pressure. It's a tendency of a solution to attract water molecules. They have ability to attract water molecules. That's why the solution of two different concentrations are separated by permeable membrane. This is a permeable membrane where they pass and that all. So I'm sure it's clear to you. Thank you for watching. Bye bye.